Good morning, dear students of class 7th. My name is Vikas, your physics teacher, and we will be continuing with our chapter Force and Pressure, Motion. We are done with simple pendulum as a topic, and now the next topic that we were discussing was scalar and vector quantities. So where we discuss the definition of scalar quantity, the physical quantity which can be described using numerical value, which we call as magnitude only or alone, is called scalar quantity. The physical quantities which need both numerical value, magnitude as well as direction to describe it are called vector quantities. Then I told you that scalar quantity is always positive. Its value, its magnitude, numerical value is always positive. However, vector quantity can be 0, negative or positive. And then the examples that we have in scalar quantity is speed, then we have time, mass, distance, and in vector quantity we have velocity, weight, displacement, acceleration. We will be studying these terms. In this chapter, we will be studying about speed, velocity, we will be studying about mass, weight, we will be studying about distance and displacement. In fact, distance and displacement is next. So let's have a look at this one, and we will try and understand it with the help of example, and that will make you more clear about scalar and vector quantity. Now, distance we said is a scalar quantity and displacement is a vector quantity. Now, let's study what are the definitions of these two terms. The actual path covered by an object or body, that is called distance. The total path which has been covered by a body, that is the distance. However, displacement, the shortest path between the initial position, that is also called the starting position, and its final position. So here we have the shortest path between starting and the finishing, the final position. Let's understand with the help of the example. Okay, so here we are again at home. This is our school, which is approximately 5 kilometers away from our home. Now, let me write. On one side, we'll do calculation for distance, and on this side, we'll do calculation for the space. Okay, so in the morning, we get up and we start our journey towards school, and we reach school. Now, when we reach school, if I ask you what is the distance covered, then you would say the distance covered is 5 kilometers. And if I ask you what is the displacement, as per the definition which I told you, we need to see what is the minimum distance between the starting and the final position. Now let's get back to the diagram. So we started from this point. Now we have reached at this point. Now what is the difference between this? That is also 5 kilometers. Okay. So when the school ends and you start your journey back. Now let's assume and you get back home. Now, how much has been the path covered? That is again 5 kilometers. So, how much distance have you covered in total? That will be 5 plus 5, 10 kilometers. This way we calculate distance, which is a scalar quantity. This is the method. Simple algebraic sum is used to calculate the total value of the scalar quantity. Now let's see for the displacement part. Now we are back at home. So our starting position was home. Now where are we? The final position, where is it? At home again. So the displacement, what is the difference between starting and final position? 0 kilometer is the displacement. Have you got it? Okay, let's try and understand with one more example. Let's see, we start from this position A and we travel, say, in one direction, straight line, and we reach point B, and the distance between this is 4 kilometers. And from B, we take a left turn and we go and reaches point C, and the distance between B and C is 3 kilometers. Now if I ask you how much path have I covered, how much distance I have covered, you would say, sir, you have covered first 4 kilometers and then 3 kilometers. We add them and in total you have covered 7 kilometers, which is right. Distance covered is 7 kilometers. However, when it comes to displacement, we need to see the starting position and we need to see the final position. What is the starting position? A. This is called initial position. Starting position is called initial position. And C, this is our final position. So according to displacement's definition, we need to find the shortest possible path. And that would be, if we join A to C in a straight line, that would be this path, AC. Now you know, as per math, you must have done Pythagoras theorem. This becomes a right angle triangle, and if we have to calculate the value of AC, this becomes hypotenuse, this becomes perpendicular, this becomes base, and the hypotenuse square is equal to base square plus perpendicular square. And if you solve it, this gives us value equal to 5 kilometers. So the shortest path, the shortest distance between initial position A and in final position C is 5 kilometers. So do you see that? Distance covered is 7 kilometers, however displacement is 5 kilometers. Okay, let's get back to the points here. So as I told you, distance is a scalar quantity. That is why it is always positive. So when we have to tell that how much is the distance covered, we keep on adding those distance, so that the final distance is always in positive. Okay? However, when it comes to displacement, it is a vector quantity. So, as a vector quantity can be 0, negative or positive, this is also can be 0, positive and negative. And the last point, distance covered by a body is always either equal or greater than displacement. Similarly, displacement is always either maximum can be equal or it is always less than the total distance covered by the body. Okay, as you can see from here as well. Do you see that the distance covered is 7 km and displacement is 5 km? And when I told you, if we start from A and we reach B, and at this position, if there is no C, we started off from A, we reached B, which is 4 km. Then the distance covered is also 4 km, and the displacement is also 4 km. So they can be equal as well. Okay, so the distance can be equal to displacement, or it would be greater than displacement, and that's always. Okay. Now, in continuation to this, let's quickly study about our next scalar and vector quantity. So before that, let me try and explain the concept here. If we have, say, 4 cars and they start from same point, starting point, or we can say starting line, and this is the finishing line. So the starting line for all the 4 cars is same. The finishing line for all the 4 cars is same. The A car starts and it covers this distance, say, in 25 seconds. Similarly, we have car B. It covers this distance in 23 seconds. And then we have car C. It takes 17 seconds. And then car D, it takes 9 seconds. What can you tell with this much information? Surely we can tell that the fastest car is car B, because it has taken the minimum time, least time to travel the same distance as traveled by car A, B and C. And which is the slowest car? You can clearly see car A. So this gives us a concept of slow and fast motion. Okay? You're already familiar with the term speed. So we always look into our speedometer and we can tell what is the instant speed with which the car is moving at that time. But there is also speed, as I told you, is a scalar quantity. Speed will only tell you how much fast or slow a car or a bus or a van or a body is moving. Nothing else. It will just give you the numerical value, the magnitude. How fast, how slow. However, there is a quantity called velocity, which I told you is a vector quantity in the example. Not only velocity would tell you how fast or slow a body is moving, it will also tell you in which direction it is moving. Because it is a vector quantity, so we need to specify the direction. Now let's try and understand this concept. Say this is Moga, and in this direction is Ludhiana. And we want to go to Ludhiana from Moga. Okay? Now, there is one car which is going in this direction at a speed of 40 kilometers per hour. I don't know how we can make a car, but I'll just try to. I hope that works for a car. Maybe we can have someone sitting in the car as well. Okay, so this car is going in this direction towards Ludhiana at 40 kilometers per hour. Now there is another car going in the opposite direction. In the opposite direction, what do we have? We have Firozpur. This car is moving towards Firozpur, say at 100 kilometers per hour. Now we wanted to go to Ludhiana. This car is going in this direction. This car is going in the opposite direction. Which car is going faster? Of course, this car is faster. And if we just look at this value only, this is your speed. And if we look at direction as well, because we want to go in this direction towards Ludhiana, so this direction will be taken as a positive direction. And similarly, this direction would automatically become negative. So, if we have to define, how do we define velocity in this? This velocity is written as that this car is going at a speed of 40 kilometers per hour with a positive sign. And this car, which is going in this direction, goes with a negative sign. This is the way we use the concept of velocity. In which direction you have to go, that is taken as positive, and the other direction is negative. So positive direction only indicates that we are going in the right direction, and negative sign indicates that we are going in the opposite direction. Okay, so let's quickly write the points as well. First, the definition part, the ratio of distance to per unit time distance covered by the body per unit time. Similarly, velocity is the ratio of displacement covered by the body per unit. You just need to note down that in speed, because it's a scalar quantity, so here we have distance. Velocity being vector quantity, so we have to use displacement. Okay, second point, those points are again same, it is a scalar quantity, so it is always positive. It is a vector quantity. It can be positive, negative, or zero. Okay? Now you need to remember this as far as the SI unit of speed or velocity, they are same, that is meter per second. Similarly, SI unit of distance, displacement, is meter. So this you can use as a similarity between, what is a similarity? This is a difference we have written. So what is the similarity between speed and velocity? Both have same SI unit. Okay? And what is the similarity between distance and displacement? They both have same SI unit, which is meters. Now let's quickly have a look at one numerical. This is all of it. So please make sure you go through this video and you understand the concept of distance and displacement, speed and velocity. These questions, the difference question is very important. You may be asked to define them. You may be asked to differentiate between these two. So be clear with it, because there are some more terms that we need to go through. That is the acceleration. We'll do it in the next video, and we will be solving some more numericals. Then we will be talking about the concept of mass and weight and so on. Okay, so it's a small question. Now before we do this numerical, please understand this, that when we say negative velocity only means that the direction of the moving body is in the opposite direction to which it has or it should go. जाना उसको इधर था और वो जा उसके ऑपोजिट रही है, तो उसकी जो वेलोसिटी वो नेगेटिव के साथ लिखी जाएगी. बस यही चीज आपको याद रखनी है, नेगेटिव वेलोसिटी का यही मतलब है. अब क्वेश्चन, a bus travels 90 kilometer towards east डायरेक्शन की तरफ जा रही है. ठीक है, तो ये क्या हुई, मैग्नीट्यूड भी है, डायरेक्शन भी है, तो ये डिस्प्लेसमेंट होगी. In 1 hour and 30 minutes. Find the velocity. ठीक है, तो सबसे पहले न्यूमेरिकल सॉल्व करने के टाइम जो गिवन है, that you would write. So displacement. What is the displacement? 90 किलोमीटर. ऐसे ब्रैकेट में आप लिखोगे in each direction. Time is given 1 hour 30 minutes. We will convert minutes into hour. 30 minutes में कितने hours होते हैं? 1/2. So this would become 1/2, 3. 3 by 2 hours. Velocity, the formula for velocity is, जैसे speed का formula displacement over time, the formula of speed is distance over time. Similarly, the formula of velocity is displacement over time. So this would become 90 kilometer. इसके नीचे 3 by 2 hours. This 2 would get multiplied with 90. Do it carefully, okay? Kilometer और ये नीचे hour, इसको ऐसे लिखेंगे किलोमीटर पर hour. This gets cut. And ultimately our velocity value is 60 kilometer per hour. This is the velocity with which this bus is traveling towards east. In east direction. ये लिखना जरूरी है. इसको हम due east लिख देते हैं. East or due east. ठीक है? So with that we end today's video lecture, and we will continue, as I told you, studying some more vector quantities and some numericals, and then we will talk about the concept of mass and weight. Please continue studying, because we are already falling behind. So have a good one. Keep in touch with studies. Have fun. Bye-bye.